All right, this lesson is going to be about angle sum of a triangle and exterior angles of a triangle. So in the previous lesson, we learned about how the sum of the three interior angles of a triangle are always going to be 180 degrees. So what that means is if we take all three of the angles inside a triangle, so in this diagram, that would be angle A, B, and C, and if we add them up, we will get 180 degrees. Now let's apply this theorem to our first example. In this triangle, we know two of the angles. One of them is 40 and one of them is 70, and we are trying to find the measure of x. So to do this, we're going to set up an equation. So I'm going to take all three of those angles and I'm going to add them together. So x plus 40 plus 70, and that's going to be equal to 180 degrees because the angles inside a triangle all add up to 180. All right, so to solve this, I'm going to combine my like terms. So 40 plus 70 is 110. And then to solve for x, I'm going to subtract 110 from both sides. So x is equal to 70 degrees. So that missing angle is 70 degrees. All right, let's take it to the next page. This time it says, now let's look at what's called an exterior angle of a triangle. So the exterior angle of a triangle is formed when all the sides, or when one of the sides of the triangle is extended. So you can extend any side, and that angle that's going to be on the outside, you can see in the diagram, would be called an exterior angle. So let's answer some questions about this. So question 1 says, what is the measure of angle CBD? Go ahead and take your pencil and trace CBD. So we're talking about this angle right here, and that's going to be on the outside of the triangle, so we call that an exterior angle. So CBD is an exterior angle. Now, it says we call angle BCA, so I'm going to trace that one, BCA. So we're talking about the angle right inside, right by that letter C. I'm going to change colors. So this angle right here. And CAB, if you trace that with your pencil, we're going to talk about this angle over here. Those two angles are what we call remote interior angles because they are the furthest or remotest from the exterior angle. So notice that the two green angles are the furthest away from the exterior angle. Okay, the one right next to it, right there, would be the one closest to it. So we're talking about the two that are furthest away from that exterior angle. So those two angles that we call remote interior angles will be equal to, when you add them together, they will be equal to the exterior angle. So that means the sum of the remote interior angles is equal to the exterior angle of the triangle. So this is what's called the exterior angle theorem. And you can see this diagram right here. So the angle on the outside, D, would be equal to the two angles that are furthest away from it if you add those two angles together. So these two angles added together will give you the the exterior angle. Now, this sounds a lot more complicated than it is, so let's head to the examples. So using this theorem that the exterior angle is equal to the sum of the two remote interior angles, we're going to look at diagram number 1. So on the outside here, we have x. That's our exterior angle. That is equal to the two angles that are furthest from it added together. So we're going to set up an equation to solve for this. So x, the exterior angle, is going to equal the two remote interior angles, so 63 and 86. When you add them together, we're going to solve this equation. So 63 plus 86, I'm just entering this into my calculator, and you get 149 degrees. All right, let's try this again. So this time, our exterior angle is over on this side here, where that side is extended. And the two angles that are furthest away, we're going to add those two angles together. So my equation, my exterior angle is x. The two angles that are furthest away are 14 and 30. So add those two angles together, and you get 44 degrees. All right, now let's make it a little bit different here. This time, it's asking us to find the measure of ACB. So go ahead and trace that with your pencil. ACB is going to be this angle over here. I'm going to call this X. That's what we're trying to find. All right, so the theorem says the exterior angle, so this is the one outside of the triangle, so that's 120, is going to be equal to the two inside angles that are furthest away added together. So X and 40. Now this is just a one-step equation that we're going to solve. So we're going to try to get X by itself by subtracting 40 from both sides. 120 minus 40 gives us 80. So that missing angle is 80 degrees. All right, let's try it again. Using our theorem, this is our exterior angle on the outside, so 20x, and that's going to be equal to the two remote interior angles. So these boxes are the interior angles, and we're going to add them together. So 7x plus 5, and we're going to add that to 60. Now let's solve the equation for x. So 20x is just going to stay, and we're going to combine our like terms on the other side. So 7x is all by itself, but we have 5 and we have 60. That would be 65. Now I want to get the x's to one side, so I'm going to move the 7x by subtracting 7x on both sides. So 20x minus 7x is 13x, and that's equal to 65. Divide both sides by 13. So 65 in my calculator. 65 divided by 13 gives us 5. So the value of x in this equation would be 5. All right, next example. Now, we have a couple things that we need to fill in. So right away, I see that this is a 90-degree angle. I think that's all we can fill in now. Now, we just learned in the beginning of this lesson that the three angles in a triangle will add up to 180 degrees. So I'm just going to trace the triangle that I'm referring to. So this triangle right here, I'm going to find this value in the corner here. That's going to be my x. I'm going to set up an equation to solve for x by adding the three angles together. And I know they'll add up to 180. So combining my like terms, 50 plus 90 is 140. Subtract 140 from both sides. So x is equal to 40. So we're going to go back to the diagram. I'm going to fill this in. Let me make this a little bit bigger here so I can write on it. So now instead of x, we're going to make that 40 degrees. Now, according to our angle relationships, I know that this is also 40 because they are vertical angles, and vertical angles are equal to each other. Now on the other side, we have another triangle. And again, we know that the angles inside a triangle will add up to 180 degrees. So I can set up a second equation to find out what that x is going to be. So x plus 80 plus 40, and that's going to be equal to 180 degrees. So I just took the three angles inside that green triangle and set them equal to 180 degrees. So 80 plus 40 is 120. To solve, we're going to subtract 120 from both sides. So x is going to be equal to 60 degrees.